Good morning students. In this class we are going to see about the topic block diagram. Why we are going for the block diagram means in the block diagram to reduce the complexity of the system we are just going for this block diagram reduction. In a control system it consists of many components and in control engineering to show the functions performed by each component we are using the diagram. That diagram has been known as a block diagram. A block diagram is a pictorial representation of the function performed by each component. So the components of block diagrams are, here there are having three main components. First one block, second one branch point and third is a summing point. First block. Block means in this for one transfer function we are giving one input as being A and output has been given as, we are assuming as B. So input A with the transfer function is given as g of s, so we are getting the output b is equal to a into g of s. Next, summing point. This is the symbol for the summing point. In the summing point, why we are using the summing point means in this, with the help of two or more signals, by adding two or more signals in the system, the summing point has been used. In this, here we are given two inputs a and c. A has been given with the input as a summing point with the signal as positive and C it has been given as negative. So the finally we are giving B has been given as B is equal to A minus C. Next, last branch point. The branch point is a point from which the signal from a block goes concurrently to the other block or summing point. The branch point means it has been either it may be moved to any transfer function next to the transfer function or with the help of summing point it may be moved. That has been shown in this. Next one, this is a block diagram with and without feedback. Without feedback means there is no feedback. Here just we are giving one input, one summing point, one transfer function and output. That is without feedback. With the feedback means we are just giving one input to the summing point next to a transfer function. With the help of the branch point it has been given to the feedback and returning to the summing point. That is with the feedback. Next one. Here to reduce the block diagram, we are going to read nearly 11 rules. We are going to follow the 11 rules. First one, combining the blocks in cascade. Combining the blocks in cascade means here they have been given two blocks. Here two transfers are two blocks and one input. First it has been taken as two blocks G1 and G2. A, the input has been given as A. In the first it will be giving A G1. It has been given to the next transfer function G2, so A, G1, G2. So finally we are getting as A, G1, G2. It has been reduced into a single block. So single block means directly we are just multiplying the blocks value G1 and G2. So the reduced form has been written as with a single block. Here they have been given one single input A with the block G1 and G2 and the output we are getting as same as before the reduction. So A, G1 and G2. So the combining the blocks in cascade means you are just multiplying the two blocks. Next, second rule, combining the parallel blocks or combining feed forward path. In this we are going to assume two sub blocks, one input, one summing point and we are getting the output. So in the input has been given to the two blocks G1 and G2. So first the A has been given to G1 means the output has been given as AG1. Same for G2, AG2. Then it has been given to the summing point and the summing point the symbol has been mentioned as positive sign. So positive sign means the finally we will getting the output as AG1 plus AG2. So it has been reduced as A has been common value. So we take down the A and A into G1 plus G2. So in this we are using two blocks and one summing point. So it has been reduced into a single block and it has been given as A input G1 plus G2. So the finally we are getting the output as same before reduction A into G1 plus G2. So the combining the blocks in parallel, combining the blocks in cascade means we are just multiplying it. Combining the blocks in parallel means you are just adding the two blocks. Next rule number 3. Moving the branch point ahead of the block. Ahead of the block means we are just going to move the branch point after the block. So here we have assumed input has been A, has been given to the block G. Next we are getting the output as AG. So has been reduced to, we told that the rule number 3, the moving the branch point after the block. So the A has been moving to the after transfer function G. So it has been given as A, G. So output has been directly it has been given as AG. But we want to get the value as A. So it has been multiplied by the block value. So 1 by G has been multiplied with that block. So the moving the branch point after the block means we are just going to multiply, add the block with the value of 1 by G. Next rule number 4, moving the branch point before the block. So before the block means there is a block value of G. So we are just going to move that branch point before the block. So the value has been given as input A, block A. The final output we are getting as AG. So we are just going to move the branch point before the block. Before the block means we are just going to same as of the block value. So we are just going to add G in the value. So the value has been given as same of previous reduction. The value has been AG. Next rule number 5, moving the summing point after the block. Moving the summing point after the block means in the summing point means it has been having of either the positive sign or negative sign. In this first without reduction we are considering A and B input with the sign of positive sign. So A plus B has been given to the block G. So we are getting as A plus B into G. Then the reduction, with the help of the reduction we are just by moving the summing point after the block means we are just going to add the block with the value of G. So here they have considered B block. In the B input we are just giving one block G. So that it has been given to the summing point as BG. Same for A input with block G. It has been given as AG. So finally we are getting same as before reduction A plus B into G. Next rule number 6. The rule number 6, moving the summing point before the block. So we are just going to move the summing point before the block. It has been having of same both the two inputs A and B inputs with the block value G. So it has been given as A input G block. So A input with the G has been given to the summing point as AG. Same for B, it has been given as B, but we are getting the output value as AG plus B. But the rule 6 is summing point before the block. We are just going to move the summing point before the G value. So it must be multiplied with the 1 by G value. Then we will be get input A. Next B with the input we told that 1 by G. So the value will be B by G to the summing point. So next to the summing point we will be get the value of A plus the signal has been given with the positive sign. So it has been given as A plus B by G. Then there is a block of G. So the final answer will be a AG plus B. Next rule number 7, interchanging the summing point. Interchanging the summing point means here we are having a two summing point. We are just going to interchange it the summing point. In first summing point it has been considered with the input of A and B with the sign positive sign. Second summing point it has been having of the C input with the negative sign. So first summing point having the output as A plus B. With the help of second summing point we are going to get as A plus B with the negative sign. So A plus B minus C has been reduced to the interchanging. By the interchanging the summing point we are just changing the second input C has been given to the first summing point value. So the final value will be A minus C as in a summing point 1. Next we are giving the input as B to the second summing point. Then the value will be A plus B minus C as before the reduction value. Next rule number 8, splitting of summing point. Splitting of summing point means in a single summing point there will be an input of 3 input. So we are just going to split into a 2 summing point. So in this first diagram we are just giving a 3 input A, B and C. A and B having a positive sign. C has been having a negative. So A plus B minus C has been splitted into a 2 summing point, with the first summing point having the inputs of A and B with the sign of positive, and the second summing point it has been having the input of C with the negative sign. So the final value will be A plus B minus C. Next rule number 9. Rule number 9 has been combining the summing points. Combining the summing point means in this there is a 2 summing point. We are just going to combine into a single summing point. 2 summing point means first in a summing point 1 it has been adding a 2 input. In second it has been adding with the another input. So we are just going to combine this 2. So combine the 2 means with the value same, A and B with the positive sign and C has been with the negative sign. So the final value will be A plus B minus C. Next, rule number 10. Rule number 10 means elimination of negative feedback loop. Elimination of negative feedback loop means in this we are just going to assume a one feedback value. The feedback has been a H. So here we are giving the summing input, summing point, one block and one feedback. In elimination of feedback loop means in this we are having one input, summing point, block, feedback and output. So input has been given as R, next block G, feedback H. So input has been given to the block with the help of summing point. So it has been given as R minus CH. Then it has been given to the block G. Then the value will be given as we will get as R minus CH into G as an output. But we told that it is a elimination of feedback. So it has been given to, once again it has been given to the input. So the value has been C has been given to the value. Then we will get CH. So the final value will be given as, if the single block we will be get as C by R. Output by input has been given by G divided by block divided by 1 plus block into feedback. That has been given as C divided by R is equal to G divided by 1 plus GH. In a summing point, if we are denoting with the help of negative means the final answer will be C by R is equal to G divided by 1 plus GH. Same in rule number 11, it has been given as elimination of positive feedback loop. If elimination of positive feedback loop means in a summing point it has been having a signal of positive sign. So then it has been the reduced value will be C by R is equal to G divided by 1 minus GH. In rule number 10 and 11 we are just denoting with the help of summing point. If it is negative means the final answer will be a positive in elimination of negative feedback loop. Same in elimination of positive feedback loop, it has been given as positive. So the final transfer function with a single block will be in a negative one. Next we are just going to see one problem by using this 11 rules. In this they have been given, reduce the block diagram shown in the figure 1 and find C by R. So find C by R means we are just going to find the output by input with the given diagram. So in this they have been given one summing point, 3 blocks and two summing point, 3 blocks and one feedback. So in this they have been having G1, G2 and G3 blocks, but in between G1 and G2 there is one point. Before summing point also there is one branch point. After G1 also there is one point with the feedback. So we are with the help of 11 rules, we are just taken the rules, move the branch point after the block. Before G1 we are having one branch point. So we are just moving that branch point to after the G1 value. So after G1 means we are giving one input R. Next the branch point has been moved after the G1. Next G2 in up. It has been having the block of G3 and in down it has been having the feedback H. So moving the branch point after the block means we are just going to multiply with the 1 by that block value. So the value has been written like this. So we are giving one input to summing point, next one first block G1 with the feedback H1. Next we have just moved the branch point. So the branch point value has been given as 1 by G1. Next it is 1 by G2. And that has been given to the next block G3 and then it has been given to the summing point. So from this we are just going to see there is one input, one summing point, one block and one feedback. So if it has been like this means we are just going to use the elimination of negative feedback. There is in a summing point there is a negative signal. So negative symbol. So we are just going to use elimination of negative feedback loop. Same 1 by G1 and G3 that it is been here continuously it has been obtained. So just we are going to combining the cascade one. Next, so after combining the cascade and elimination of negative feedback loop, we are just getting the output as input. First we are getting the input by help of elimination of negative feedback loop. It has been given as G1 divided by 1 plus G1 H1. Next it has been given to second block, that it has been used, we have used the cascade method. So G3 divided by G1, then next it has been given to G2 and one summing point is there. So we have used one cascade method combining the rules, combining the blocks in cascade. Next, elimination of negative feedback loop. Next, moving the branch point after the blocks. Three rules has been used. Next, the combining blocks in parallel. So combining the blocks in parallel means we must in need of two blocks with one summing point. So in this G3 by G1 divided G3 by G1 one block. Next G2 has been one block. Next one summing point. So it has been written as G2 plus G3 by G1. So finally we are getting as one value has been elimination with the help of elimination of negative feedback loop. We are getting G1 divided by 1 plus G1H, and with the help of parallel blocks we are getting G2 plus G3 divided by G1. So finally we are getting the output of C by R as G1 G2 plus G3 divided by 1 plus G1H. This is the overall transfer function of the particular system. With the help of the block diagram reduction, with the help of 11 rules, we are just reducing to the transfer function output as C by R has been given this. Thank you.